Hi everyone, my name is John Coughlin. I'm on the community relations team at GitLab. I've been at GitLab for more than 4 years. I actually started as a program manager, and the program that I kind of launched and managed when I first joined was our Meetups program. And so it's really cool to still be involved in our Meetups and in the community, and it's certainly been one of the highlights of my career. So really excited to be here and be hanging out with all of you today. At GitLab, one of our values is diversity, inclusion, and belonging. And so in order to ensure that the community remains a welcoming and inclusive place, we ask that all community members abide by our code of conduct. I'm going to drop a link to that in the chat. If anyone, wants to review that, I'd encourage you to do so. If anyone is having any kind of issues or would like to report a violation of this code of conduct during the event, feel free to just send me a DM via Zoom. So if you're not familiar with Zoom, you can do that by going into the Zoom chat, toggling from kind of everyone in the meeting to my name, and then sending me a message. That'll be the most efficient way to reach me. If that's not possible, you can also email conduct@gitlab.com. So with that, just wanted to say thanks for being here. For folks who are new to kind of GitLab, not familiar with GitLab, we're a complete DevSecOps platform. So it's one interface, one data model, one permission model. All of your conversations are happening in one place. We have thousands of features and that require no context switching between different applications. And so it's really just the complete DevOps platform that you and your team need to deliver software faster. We're also an open core company, so we have an open source version of our product that anyone can use for free and anyone can contribute to. Other cool things about GitLab, we're one of the largest all remote companies in the world. I used to be able to say largest, but now with the kind of post-COVID work environment, I'm not sure if that's totally true anymore. We have like a ton of resources on remote work in our handbook, which is completely public, and you can find out all the things about how we run our business, not just how we work remotely, but everything that we can possibly share about how we run GitLab is in our public handbook. So for today, we're going to go through a presentation from the team at Hopper and EITR. Just a couple small requests, as I mentioned earlier. If you're comfortable being recorded, it'd be great for you to keep your cameras on, but no worries if you're not comfortable doing that. Please stay muted during the presentation. If you do have questions, it'd be great to use the chat to ask those rather than interrupt our speakers. We're also going to have time for Q&A at the end. If you haven't already, it'd be awesome if you could share your location in the Zoom chat. I'm joining from New York. It seems like there's a couple of folks from Maryland, actually a lot of folks from Maryland, but I'm sure they'll get to that in their introductions in a second. And I would just say, close Slack, close your other tabs, and just kind of try and be, attentive and enjoy the great presentation that these people have worked hard to prepare for us. So with that, I'm going to pass it over to Tom.
Thank you, John. Good afternoon, everyone, or whatever part of the world you may be tuning in from. My name is Tom McNamara. I'm the founder and CEO of Hopper. We build a automated moving target defense technology that protects workloads and APIs in the cloud. And today we're going to be giving you a presentation about how we do this with hardened tunnels. But we're also going to be stressing and talking quite a bit about how we use GitLab. And so my colleagues from EITR have partnered with Hopper to develop this technology and the product that we're taking to the market. So Nick, next slide, please. So Nick, who is running our slides right now, will be joining us in the presentation later, is a co-founder and CEO of EITR Technology. He's really been the chief architect, if you will, of the product that we're going to talk about today. He is also dual-hatted as the VP of our product engineering at Hopper. And he is joined by our other co-founder from EITR, the CTO, who is Stephanie Pfeiffer. She is our GitLab expert, and you're going to hear a lot of good things about how she has done a lot of magic with the GitLab Ultimate license. So with that as introductions, let's go to the next slide. And I'll talk first about the problem that we're solving. So as I mentioned at the beginning, we have an automated moving target defense technology to protect workloads. So the challenge we're trying to solve is really about who are these workloads? How do we know their identity? How do we trust their identity? How do we know the credentials that we're getting are in fact from legitimate sources and not from a man-in-the-middle attack? And of course, we would all like to see mutual TLS everywhere, but it's not really possible or practical to get that. There are places where MTLS terminates in the cloud and we don't have any control necessarily over that. And it's very difficult sometimes to put MTLS into place everywhere because of its dependency on PKI and certificates and those types of things, which I won't get into. But it's a great goal to achieve. But what we'll talk about today in hardening these hardened tunnels is essentially an MTLS everywhere alternative. And I'll talk more about that on the next slide. The other part of our problem we're solving is the friction that developers and DevOps confront when they're trying to implement TLS or MTLS outside of clusters. They're trying to implement it with automated certificates authorities and PKI infrastructure. It's a lot of trial and error, a lot of configuration, a lot of friction really in getting that deployed and working properly. And of course, all this adds up to cost, people cost, time cost. There's also dependencies on cloud vendor services and the cost associated with key management systems and certificate management systems, secrets managers, et cetera. Next slide. So what we've done is to develop a solution that uses a technology we call codes hidden in plain sight, CHIPS for short. And it's both a technology and a protocol. Nick will be talking about that more towards the end of our presentation. But essentially what it does is it builds an identity and a secret credential for each workload. And it does that constructing of those two credentials at the workload itself. And then we rotate both of those credentials at a very high frequency once every session so that they're constantly changing and being refreshed. And then with that secret credential, what we do is we use that within the workload to actually build a end-to-end encrypted tunnel on demand. And we're able to do this without ever going through any handshakes or any key exchange. And the final part of our solution that we're quite happy about is that we've been able to package all of this into a simple container. So it's deployed as a sidecar with each workload. And it makes it really easy in a DevOps friendly way to essentially get what's the equivalent of MTLS everywhere, but on steroids. Next slide. So to give you an idea of what I mean by the on steroids comment, you know, this slide shows a topology of two organizations. One is a bank in the green circle and a payment processor, and they have control over their own environments, their own workloads, their network security, et cetera. And so they may be able to do transport security and authentication and trust the workloads in their environment. But when they go outside that to the bank, for example, or between the payment processor and they try to make connections, the trust isn't there. So we've come up with a way in our solution to use these hardened tunnels along with our CHIPS technology to essentially protect data all along the entire route here, where you see the blue and green lines. And the blue lines are a product we call XTRA. Nick will talk more about that. And the green line is the product we call Kerberos for the Cloud, or K4C. And at each of these workloads that are out in any cloud anywhere across these vendors, there's a Hopper sidecar that does the management essentially of the identity and the secrets rotation for those workloads. So with that as a background to what we are trying to solve and how we've solved it, I'd like to turn the presentation over to Stephanie Pfeiffer. Stephanie is an expert in GitLab, and she's done an excellent job in sort of managing the development of both XTRA and K4C for Hopper over the last 9 months or so. So Stephanie, over to you.
Thanks, Tom. I appreciate it. GitLab's really been able to power our team to organize our communication, our tasks breakdown, and enable us to do continuous integration and deployment and delivery really seamlessly. So we're excited to jump right in here. So Nick, let's go to the next. Thank you. First, we're going to jump into our project tracking. In the past, I've used Jira a lot, and I think GitLab's really giving Jira a run for its money with their project tracking and management. At Hopper, oh, and one thing to keep in mind that Tom did mention earlier, we're using the GitLab Ultimate license. So if any of this doesn't look familiar and looks super cool, which it does, you should definitely check out the Ultimate level of GitLab because it is very helpful with these products. So at Hopper, we take our architectures and our tasks, and we break that down into a milestone, which is a set of time that we want to get accomplished certain things. Each of those things gets captured inside of an epic, and we can link our epics together now inside of GitLab so that we can say this major piece of work needs to be done before another piece of work needs to be done, which is in that top right-hand picture on our slide. Each of those epics has a set of issues inside of them, and those issues are linked together as blockers or dependencies to be able to make sure that as a developer, when I come in here to figure out what I need to do next, I don't have to have oversight from my manager at all times. I'm able to just look at this list and see what I need to do next and what's blocking what. So it really gives the ability to manage my workload easier as a developer and to come up with tasking as a manager a lot easier. We leverage labels for prioritization, and they are based off of the GitLab recommendations. They are in the screenshot in the lower left-hand corner, and we use things like priority 1 to say these are the important things we need to do now, all the way down to priority 4, which it needs to get done. But if I have a critical bug, obviously I'm going to attack that first. A really great thing about how GitLab does their issue tracking is we are able to keep even our issues and our accesses to our repositories dry. Don't repeat yourself. So I don't want to add people to a bunch of different repositories. I don't want to go through adding additional users to issues. So they give us the ability to make confidential issues and confidential epics. And those permissions trickle down from the epic level all the way to the issue. So if I need to integrate another external team into my GitLab group, I have the ability to keep the things that I'm working on that they don't necessarily have a need to know to safe. And that's a great lead into our next topic, which is the GitLab Service Desk, which is a fabulous integration between customers and support. Customers are given basically an email address that they can hit, and that will trigger an issue created in our service desk queue. And that issue can go back and forth between our developers without us having to add every customer to our GitLab instance. And we're able to communicate back with our customers via comments on the issue. So it's a streamlined interface between our customers and our developers and our support team to make sure that we're attacking the things that customers need and simplifying that workflow. You can see in our screenshot on this page, we are also using the templates that come along with Service Desk, where you can add new notes, thank you notes, whatever templates are going to help in your workflow to make sure that your customers understand that they're getting the feedback that they need. That way you're not reinventing the wheel every single time you want to send a note. The Service Desk has been really valuable, especially for that communication. So you can jump to the next slide to our security features. So GitLab, and some of this starts bleeding into the ultimate level license, but the security features really start with the security dashboard, which is in that top right-hand corner of your screen. All of our projects get reviewed automatically, and we can see a nice report of what level, what grade we're getting on our projects. As you can see, over the last 90 days, we've had pretty much straight A's at Hopper, which is excellent. And as issues come up, we can be proactive because the dashboard is giving us the ability to see what needs to be addressed. And while dashboards are great, reports are very important. And as you can see in the middle of the screen, we have our vulnerability report. I don't know how to talk anymore. Our vulnerability report is going to give us an overview of everything that GitLab has been able to see as an issue on our projects. There are some simple ones in the bottom, and you can see they go from critical down to low, and there are even informational issues that they found. And the thing I really like about this is it links directly back to a project. You can create issues off of these. It gives great visibility. It gives descriptions. It's awesome. And for those informational alerts that probably don't need anything done for them except for a little bit of documentation, you can get rid of those by just clicking, hey, I'm going to ignore this issue. This actually is okay. I don't need a new magic number every single time. So I think it gives a really great visibility into our security features. They are reporting on things that, are commonly overlooked maybe because they're so simple, but having that visibility is really great, especially automatically. So now we can jump to the next slide and talk about my favorite part of GitLab, which is the CI/CD. On the Hopper side, we're leveraging shared runners. We try to have as minimal infrastructure as possible, and the shared runners give us the ability to just run inside of an environment GitLab's already provided for us. We are using a blend of the custom Hopper templates as well as the standard GitLab CI templates. The templates are great because they're largely universal and address common and often overlooked issues. And the Hopper templates are generic and streamlined for use cases across all of our technology sets. So you can see in this diagram, we have a custom template called workflow.gitlab CI that we leverage to make sure that we're not going over our minutes and making sure we're only running pipelines when we need to. But in the bottom part of the diagram, you can see that we're bringing in the security, license scanning, dependency scanning, SaaS templates that are provided by GitLab to make sure that we're getting that security scanning. So the blend between those two really gives us that holistic GitLab CI pipeline that's going to help our projects be as robust as possible. So if we go to the next slide, we can see it in action. Here are some diagrams of the pipelines that we are using today. So you can see we have standard stages like pre-commit, test, build, and then we diverge and build and deploy on whenever we need to, create a tag, put something out to our users, or just build and make sure that everything is working okay. Our custom pipelines integrate with Python and Golang and the languages that we're happening to use at the time, and they give that streamline where I can use it in any single Python project, any Golang project that I'm using. And we use these pipelines to deliver to internal repositories at GitLab, like Container Repo and PyPy. And we also use it to integrate with our external repos for our customer-facing deliveries. We're leveraging Harbor at that point. But that seemed to be the happiest medium between leveraging all of the GitLab things and then one external customer-facing thing, which I think is pretty awesome from an architecture perspective. So I think that's my last slide, and I'm super pumped up about GitLab now. So I'm going to hand it over to Nick, who's going to give an overview of architecture and what we're doing here at Hopper. Take it away, Nick.
Thank you, Stephanie. I especially like the part about the vulnerability report.
I did that just for you.
Yeah, that was my favorite part by far. So Stephanie said, I'm going to talk a little bit about our architecture before we get into kind of how the products themselves work. Great lead in. Stephanie mentioned the container repositories and how we have an external one for our customer environment. It gives us the ability to have this promotion process where, when we cut tags on a repository, it'll go ahead and build artifacts that we can go ahead and test internally before we say, okay, this is ready for customer consumption. So right now that is a manual promotion process. You can see we have the little gear button there that somebody has to go in and click when they're ready to promote. But we do have plans to automate that process as we get a little bit more mature in our processes, maybe run some canary builds or something like that, and then go ahead and promote containers that pass from there. As far as our basic architecture for a lot of the services that we run, we love containers. We have The container repositories that our images live inside of that we're building has all of our products bundled in. And so what that gives us the ability to do is, leverage container orchestration frameworks like Fargate and ECS in AWS or really any other cloud platform. So you can see we have here, your basic networking setup where, we have individual network interfaces that are attributed to each workload, internet access, inbound and outbound through an internet gateway and NAT gateway, respectively. And where we have web services, we're generally fronting those with ALBs and WAF, but we do have some for some of our tunnel frameworks that aren't layer 7, so we have NLBs in front of those. And as I said, the containers really give us that portability to move things around wherever we'd like. So we can, move our whole setup over into Google Cloud, into Azure, wherever we'd like, just because all of the important things are bundled into our containers, right? Our processes in GitLab build those containers out for us and house those. And it's really just a matter of writing the infrastructure as code in order to draw those containers in and put the infrastructure surrounding them that they require in order to run. From there, we can have like a global load balancer like DNS, point customers at our services in whatever cloud we'd like. And I don't want to get too much into our infrastructure as code setup, but I did allude to the fact that we write infrastructure as code for all the things that we do. We leverage Terraform for all of the things. And in addition to that, we do use the TerraGrunt wrapper outside of that in order to keep our infrastructure as code dry. So we do write all of our Terraform as modules and then reference the modules and pass variables in order to get those spun up. One of the other things that TerraGrunt gets us is the ability to create and destroy entire stacks of infrastructure. So, if you've ever used TerraGrunt before, you have the apply all command, which is really nice. You can keep all of your infrastructure pretty atomic, and then use apply all to reach into substructures of your infrastructure as code directories in order to spin up large pieces of it all at the same time. So that was a quick overview of our architecture. Let's dive a little bit deeper into our products. We will lead off with kind of the cornerstone of everything that we do. Tom mentioned chips. This code's hidden in plain sight. Essentially, what that allows us to do is provide the seeds for all of the encryption mechanisms that we leverage inside of our products. And it's really an awesome way to derive keys on disparate ends of a communication pipeline and not have to perform any of that key exchange. So kind of the way that this would work is, say you have some sort of dynamic data on the internet. In this case, we have an RSS feed URL. And if you get this from any news source, it's probably going to be changing pretty quickly, right? You have the news cycle is pretty quick. Something's always happening in the world. And so, we have new headlines coming into our feed all the time. So what we do is we reach out to that feed, we grab a predetermined headline as identified inside of a particular algorithm. It's just a series of steps that we're going to go through. That same algorithm also tells us how that headline data is going to be transformed. So maybe we have certain characters that are replaced with other characters. Maybe we are breaking it up into pre-described chunks and moving things around, shuffling stuff up. Each algorithm that we have in our stack allows us to do different things to that data. And then finally, we create the key from the data. So, we have workload A and workload B that are attempting to talk to each other. We have them configured both for the same algorithm. For the sake of brevity, we'll call that ABC123. And if they are both configured for the same algorithm, they can both independently derive the same key for encryption between the two endpoints. At this time, we have over 42,000 algorithms that are part of our default stack. Why 42,000? As we all know, the number 42 is the answer to the ultimate question. And so, it just sort of fell into place. We are also leveraging Envoy as part of our stack. It is a great open source project that underpins a lot of different products in the container ecosystem. So if you're familiar with Istio and maybe some other service mesh applications, they all use Envoy under the hood, and so do we. And what that allows us to do is, in addition to all of the things that we add as an Envoy filter, you gain access to anything else that you can do in Envoy as well, which is really nice. So it gives us a lot of flexibility, gives our customers a lot of flexibility to do whatever they'd like, in addition to having our filters in the stack. And so, you can see that maybe we have a requester and a responder in this communication stream. Each one has an Envoy sidecar that is close to it. And as the requester reaches out downstream, Envoy handles that data. Our filter performs the encryption. It travels across the wire downstream to the other side, where Envoy handles it again, decrypts it, hands it to the responder, and then it comes back the same way. So how do we apply those concepts to our products that Tom mentioned at the beginning? We have XTRA and K4C. We'll start off with XTRA. So in this scenario, we have workload A and workload B. For the sake of argument, they are inside of the same organization here. And if they want to talk securely to each other, workload A has an algorithm configured. It reaches out to its predetermined internet source and derives that key using the CHIPS algorithm that we discussed before. So now that it has its key, it reaches out to workload B with some encrypted payload. Workload B says, hey, what's going on here? I just received some encrypted data. I don't know how I'm supposed to decrypt this. Let me go ahead and get my key, and then I'll go ahead and be able to decrypt it. So it reaches out to the same source, which is configured by that algorithm on each side. And now it has the same key that workload A has, even though they didn't have any key exchange, and it can decrypt the payload. That operation is performed for every session. So you can have n number of communication back and forth between the two workloads inside of that same session, and you won't have to renegotiate the key or go through the process again, I guess. If we were to start a new session, obviously we'd have to go through the key generation process, and it would be rotated at that point because we have the the rotating data that is present in our RSS feed. So now we'll transition over to K4C, or Kerberos Cloud. In this scenario, we have two different organizations. So we have Org A and Org B. You can see that each one might be talking within its own organization using a certain key. This key that is shown on each side, the blue key on the left and the green key on the right. Those are configured by DevOps engineer when the software is deployed. The algorithm is, and then the key is derived the same way that we've shown before, right? Chips is involved in the process, and the same key generation process that we see in XTRA is used in K4C as well. When Org A wants to talk to Org B, essentially what we have here is Hopper in the loop as a trusted third party. So the way that this works is Org A reaches out to Hopper and says, hey, we're talking to each other with our pre-negotiated blue key here, that every organization would have its own. So you know that I'm me because of that. And also I have this rotating workload identity as well. This is a concept that we introduced into the product so that you sort of have this chain of custody for identity, which is kind of unique in its implementation versus PKI, because what we have in our machine alias identity is this concept of, hey, we're workload A, we have a specific identity, and then at some interval, it's going to rotate, but we know that workload A had its first identity and now has its second one, and then subsequently its third one, and we can trace that chain back. What you generally get with PKI and an MTLS setup is, say you have workload B, it has a certificate assigned to it. If that certificate needs to be regenerated, or it expires and needs to be reassigned, it's kind of its own new entity, right? So workload B on the left, is now expired. It can't be used, but there's no link between it and the next workload B identity or the subsequent workload B identity. All you get is this trusted authority that says, like, yeah, this identity is good. So, if you haven't revoked it and it hasn't expired, it's okay. But other than that, there's no way to chain between those identities. So that's one thing that makes our machine alias identity unique. So we've already established that Org A has more or less authenticated with Hopper and said, hey, I'm me. I'm trying to talk to Org B. Can you help me out? Can you sort of negotiate that and arbitrate that communication? So Hopper will go ahead and develop a key for use between those two organizations. It's not related to the blue key or the green key that we see in this picture. It's its own entity, this purple key. And inside of the same session where Org A reached out to Hopper and said, hey, I want to talk to Org B, it's provided this purple key to do so. So now I can reach out to Org B and say, hey, I got some encrypted data for you. Org B is like, all right, well, I got this new encrypted data, but I don't know what the heck to do with this thing. Let me go talk to Hopper and see what's up. So at that point, it reaches out to us and we have queued up this key. So the same encrypted path and negotiation takes place between org B and Hopper, right? It's using its configured green key in order to secure that communication. And it is able to retrieve the purple key that's waiting for it, so they can communicate with org A. So at that point, org A and org B have that purple key, and they can talk a number of times inside of the same session, just like we would with XTRA. So on that note, I'm going to do a brief demo. We're going to do this via video because I don't want to anger the demo gods. And so I'm going to load that up real quick. This video is a recorded demonstration of Hopper's moving target defense solution that protects workloads, APIs, and data with end-to-end encrypted tunnels. We'll demonstrate the simplicity of deployment and how Hopper's solutions work in operation with deployed workloads in the cloud. The video is in two parts. Part 1 explains the organization of the YAML file and the settings that a DevOps engineer would configure at deployment. Part 2 is a demonstration of Hopper sidecars in operation after they have been deployed with separate workloads. I'll show how the end-to-end encryption occurs in each session and protects endpoints by securing the data communication. We'll also see how it blocks any untrusted connection from reaching a protected endpoint. Let's look at how easy it is for a DevOps engineer to achieve end-to-end encrypted tunnels for their enterprise workloads. It is a simple process of editing a YAML file when deploying a workload to production. As far as the XTRA product for Hopper is concerned, we are going to quickly go over the configuration of the product, which is pretty easy. We provide some artifacts that enable point-to-point communication, and those can be extended for any types of communication scenarios that you might have. So just running down this really quickly, we have some Kubernetes artifacts here that we'll be showcasing, and we have a namespace that everything is going to be deployed in, a configuration map that will be used by Envoy, which is a very popular open source project that's used as the underpinning for a lot of Kubernetes-based projects, including Istio. So we have the full Envoy configuration syntax that's available to us. And so that outlines some real basic routing and filtering that we'll be performing in this demo. Then we have a web server script that we'll be using to show that we have, in fact, reached the other side of a communication point-to-point setup. And then we have some registry credentials that we use to contact the Hopper repository for pulling down containers into our Kubernetes environment. But this secret here is really the one that most customers will be interested in, and that is our license key that we use to enable features within the XTRA and other Hopper products. And then the CHIPS algorithm. We currently have thousands of algorithms that can be used with chips in order to distinctly identify the algorithm that will be used between two endpoints, so that somebody can configure both of those endpoints with the same algorithm and effectively have them source identical keys independently of each other. We also have some other mechanisms here for our deployment. We'll be deploying some test containers here. You can see that we have a curl test, which will be sort of like the client side of our demo communication endpoints. And then we have a web server here. It's running our simple web server script, and it's going to have some text on it so that we can see that we have reached the other side of the tunnel, if you will. And then we have our Envoy container and our key server container, which comprise the XTRA product. So once we have that implemented, essentially we have communication between two sides here. We have on the top our Babar node, and it is reaching out to the Cornelius node. And you see it's getting a response back here. So every 30 seconds, the curl test container is reaching out actually locally and hitting an Envoy endpoint that is then filtering and sending it on across the internet to Cornelius. And Cornelius is doing the same thing, but in reverse. So it's getting out over to Babar, and all of this communication is happening over the internet in an encrypted fashion through XTRA's functionality. So the curl command itself is not encrypted. You can see that we're reaching out to an unencrypted web server. So there isn't any TLS or anything that is involved in encrypting this. It's encrypted end-to-end by Hopper in transit. So if we have a third endpoint in the mix and we wanted to try to connect one of our secure endpoints, you can see that if we try to reach out to Babar from our third endpoint here, which happens to be my laptop, we don't get a response back. Right now, the communication that's occurring from my laptop to that endpoint is being initiated. It goes over the internet. It goes into the XTRA software. And effectively, since it's not encrypted, it's being black holed. So there's no response that's coming back, which is useful when you have application endpoints on the internet. Any type of response that you have, even rejections, can positively identify the existence of an application. So we are black holing that. That's effectively being dropped. But if this endpoint was a legitimate endpoint, all we would need to do is run the XTRA software on that endpoint. We still cannot access the internet endpoint directly. However, what we can do is we can access our local egress to that endpoint, which is being served up by Envoy. And you can see that we have accessed the listener port on localhost. However, we have gotten to the web server endpoint for Babar. So all of that encryption occurred between my endpoint and the Babar endpoint. And every single session that we initiate will have a new key, potentially, based upon the aggregation of internet information. So that allows me to have separate keys used between sessions on the same host, and then also between separate hosts, but all using the same algorithm. All right. And so that brings us to the end of my segment as well. Appreciate everybody's time listening to all of that. And now we'd like to open up the floor to any questions if we have them.
Thanks, everybody. Really cool presentation. I got to admit, I was a little biased to Stephanie's section, but I thought the whole thing was great. To go back to Stephanie, you mentioned that you use Harbor to connect like into your kind of customers. Can you explain a little bit about how that works?
Sure. Nick might be able to jump in as well, but for our internal repository, when we are doing testing, we push our containers to container repo inside of GitLab. But when we want to publish those containers to our external customers and give them a common space for them to grab new Docker images from, we push it to our internal Harbor instance that they have access to. It's just I saw you on mute, Nick, so I'm gonna let you jump in.
Yeah. Basically what the external Harbor instance allows us to do is have separate authentication for our customers coming into Harbor, and also it allows us to go through that promotion process. So we won't necessarily allow customers to be able to run, quote unquote, bad versions or whatever, right? So if we happen to have something that squeaks through the cracks and gets deployed to our internal GitLab repository, our testing processes should catch that before it's promoted. And it's kind of like an air gap almost in our promotion.
Got it. So the internal kind of registry is like almost like your testing, and then Harbor is kind of like your prod for these container images.
Yeah, pretty much.
And then Karan had a question in the chat. I'll just verbalize it. So are DevOps engineers using this? And then I think Tom responded.
Yeah, I think our expectation is the DevOps engineers handle the YAML and the deployment on the customer side.
Yeah, all of that stuff should look familiar to DevOps engineers, right? Any container orchestration framework like Kubernetes, the DevOps engineers are familiar with. It should be really easy to get this up and running in short order. So we made the choice to steer towards technologies that folks were going to be familiar with. And we didn't want to put anything out there that was going to be so crazy and complex that it was going to take forever to get out there, right? Like that's one of the main things that differentiates us between what we do and the traditional PKI infrastructure that is required for something like MTLS is that generally those setups for MTLS are quite complex, at least if you're doing it right. And so we are a much simpler thing to get ready, but just as strong, if not stronger, in identifying the workloads and securing them.
Awesome. Does anybody else have any questions? All right, I think in that case, we'll wrap it up. So yeah, wanted to just say, thanks to, Nicholas, Stephanie, and Tom for the presentation today. Really interesting, really informative, and great to learn about how you're using GitLab. And yeah, for everybody who kind of came out for the event, thank you for your time, attention, questions. I noticed that I think everybody who's, in this room had RSVP'd for the event. So you can always go and ask any follow-up questions you have about the content on the Meetup page. And if I see anything popping up there, I'll be sure to flag it for today's presenters. So, thanks again for your time, your attention, and being part of the GitLab community. And I hope, we'll see you at a virtual or in-person GitLab event sometime soon.
Thank you, everyone, for your attention today. Have a great week.
Take care, everybody.